Good morning, learners. My name is Mr. Paul Chilola once again, representing Black Slides, who are the tuition providers online. We meet this time for a lesson in mathematics, Form 4 mathematics, in a topic called probability. All right. So this is a topic which you learn in Form 4, which is called probability. Without further ado, let's look at some important terminology which are used in this topic. Such as outcomes and events. What are outcomes and events in relation to the topic of probability? This is not the first time you are meeting this topic. You have met this topic again before in Form 2, where you looked at the probability of single events. In this topic, Form 4 topic, we're going to look at probability of combined events. So, you learned in Form 2 that an event can have several outcomes. An event can have several outcomes. For example, when you throw a 10-sided dice, a 10-sided dice, a dice with 10 sides. All right, a dice of 10 sides. A dice of 10 sides, when it's thrown, it will show you 10 faces. So in this case, throwing a 10-sided dice is an event. All right, whose outcomes, possible outcomes, are the 10 faces. A face which shows up when a dice is thrown is an outcome. So there are 10 possible outcomes. Each outcome representing one or a face that is seen from the top, like the face that faces upwards, which may be numbers 1, to 10. So each number is an outcome. The event involved is throwing a 10-sided dice. The outcome or outcomes are the numbers that face up after throwing. So from 1 to 10. Can you think of an event that has 2 outcomes? Alright. An event such as walking. When you are about to start walking, let's say you are walking to class from your hostel, you can either lift one leg, the left leg or the right leg as you start walking. So in that case, walking is an event. And lifting a left leg or a right leg when you start walking is an outcome. You cannot lift both legs at the same time. It's not possible. So the outcomes in that case are left leg or right leg being lifted first. A simple example of an event that has 2 outcomes is flipping a coin. When you flip a coin, the coin has 2 faces, heads or tails. So a fair coin, when it tossed or flipped, will show one or either of the 2 sides. So flipping a coin is an event, while the side showing heads or tails is an outcome. So a coin has 2 faces, therefore each face represents an outcome. You can think of other events that have 2 outcomes. Alright. Okay. Can you think of other events which produce 2 outcomes? This is just one. Flipping or tossing a coin. And also note that the coin needs to be a fair one. A fair coin. A fair coin. A fair coin is one which does not stand on its edge. But falls on either of the 2 sides, which is the heads or tails. All right. Very important, Okay, so we are saying a simple example of an event that has two results or outcomes is flipping a coin. All right. So the two outcomes of flipping a coin. So flipping a coin is an event. The two outcomes that are likely are heads and tails. All right. So each outcome of a given event has a probability. So we come to defining probability now. Probability is simply a likelihood of something happening, or the possibility that something is going to happen, an event is going to happen, to produce outcomes. So we are saying each outcome of a given event has probability or chance of happening or occurring. All right. So if you go back to the example of throwing a 10-sided dice, remember a dice has 10 faces. A 10-sided dice, I mean, has 10 faces. So what is the chance that each face will show up? To show up means to be on top. Alright, so what are the chances of each outcome from throwing a dice? So assume that the dice is fair. Fair means that it cannot show two results or three results at the same time. No. So the chances of each outcome occurring is 1, because each number on the dice exists only once. For example, you have 1, there's 2, there's 1, 2. In other words, each number is appearing once, or each number has a chance of showing up only one time. So the probability of each number on the 10-sided dice is 1 out of 10. Can you think of an event that has two outcomes which have probabilities that are not equal? All right. One example of probabilities that are not equal, that will not be equal, is choosing a person with that will be right or left-handed in your class. If you go in class, there are some people who are left-handed and others right-handed. Left-handed people are those who use their left hand to write, and the right-handed people are those that use the right hand. So in most cases, you find that there aren't many people in your class that are left-handed. There can be 2 or 3, or maybe sometimes 1, or even none. So the probability of a person who is called out to meet the head mistress or anyone outside, such that that person is left-handed or right-handed, may not be equal to the other one. All right? Let's say there are 2 people who are left-handed out of maybe 60. So the probability of a person called out at random is going to be left-handed is going to be maybe 2 out of 60. And that is not equal to the probability that another person picked at random is going to be right-handed. You can think about other examples. Now, look at these examples of events and say whether in each of these scenarios the outcomes are going to be equal, or will have an equal chance of occurring. For example, the probability that it's going to rain. It will rain tomorrow. That's one outcome. It will not rain tomorrow. That's another outcome. So it can either rain or not rain. Do you think these 2 outcomes are equal to each other? In my opinion, yes. Because if it does not rain, that's an outcome which is equally likely to it is going to rain. So it can either rain or not rain. It cannot rain and rain at the same time. No. What about a child born will be a boy? Assuming that boy and girl are the only outcomes, what is the scenario here? Is the fact that the child born is a girl equal to the probability that it's a girl, or probability that it's a boy? Of course, when you're looking at this scenario here, you should not forget also that we have some children who are called transgender. You can have females, all right? People with both sexes. But let's suppose that is not the case. We are just looking at boy or girl. The child born is a girl, or the child born is not a girl, is a boy. Are these equally likely events? Think about it. Suppose you flip a coin. You flip a coin or toss a coin. A coin has 2 faces. It can either show heads or tails. Are these equal to each other? Alright. Is showing a head equal to showing a tail? That's what we mean here. Right? We are examining which outcomes are equal, have equal chances of occurring. That is going to rain and that it is not going to rain. Are these equal to each other? It cannot rain and rain at the same time. All right. You can either have a male child or a girl child. Here we are ruling out the possibility of having a sex which is both female and male. What about a number selected at random from 1 to 100? Will be even? Even number, you remember? Even numbers are those numbers that are divisible by 2. Like 2, 4, 6, 8, 10, 12, 14, 16, and so on. Those numbers that are divisible by 2. So divisible by 2, not by 10, but divisible by 2. Are called even numbers. Do you think the number of even numbers and the odd numbers is the same for the numbers from 1 to 100? Suppose you pick a number from 1 to 100. Is picking an even number the same as picking an odd number? Think about it. Suppose we throw a dice once. This one is with respect to the 10-sided dice. Is the probability of showing a square number the same as showing a non-square number? Squared numbers are numbers like 4, 9, 4 and 9, including 1, because when you square 1, you get a 1. Square 2, you get 4. Square 3. Alright, so squared numbers for numbers between 1 and 10 are 1, 4, and 9. Alright, is the probability that it is a square number the same or equal to the probability that it is not? Just count the number of square numbers and the non-squared numbers and check that out. The next person to walk into the room will be right-handed, and the next person to enter the room will be left-handed. Are these equal events? Okay. The bus will be on time tonight, and the bus will not be on time tonight. Are these events the same or outcomes the same? The probability that the bus driver will be female and the probability that it will be a male, are these equal? When a dice is thrown once, it will show a prime number. Prime number is a number which does not have any other factors except itself and a 1. Numbers like 2, 3, 5, 7, 11, 13, those are prime numbers because they don't have any other factor. You cannot express them in simple as product of other numbers except the number itself and the 1. So for a dice that has 10 sides, is the probability that a number picked is prime and that it is not prime the same? Alright, that's very good. Probability can be measured from 0 to 1. This means that the probability of an event occurring or producing an outcome cannot be less than 0 and cannot be greater than 1. So if an event is impossible, meaning that it cannot occur, cannot produce an outcome, we call it an impossible event. So if an event is impossible or has no chance of occurring, then it has a probability of 0. If an event is sure, 100% is certain, then it has a probability of 1 or 100%. So we are saying a probability can be 0 if it is impossible to occur, or if it has a 50-50 chance of occurring, it is said to be even, so it's half. If it is 100% certain of occurring, then it has a probability of 1. So we have an impossible event, a certain event which is 100% sure of happening, and we have a 50-50 chance. We call it even chance. So probability of something occurring, an event occurring, cannot go beyond 1, or it cannot go below 0. So probabilities are written as fractions. They can also be written as decimals. And in very rare situations do we represent them as percentages. Let's look at how we calculate probabilities. If the outcomes of an event are equally likely, then we can calculate the probability using this formula here. Probability of an event, for example, tossing or flipping a coin. A coin has two faces, heads or tails. Is calculated by using this formula. It is equal to the number of possible successful outcomes divided by the total number of possible outcomes. In case of flipping a coin, it will only show one face up. It can be a head or tail, so it will be 1 here. Number of possible outcomes is 1, but a coin has two faces, so the total number of possible outcomes is going to be 2. So tossing a coin, flipping a coin shall give you a possibility of 1/2 for head and also 1/2 for tail. For example, a bag contains 1 yellow, as you see here, this is yellow marble, 3 green ones, 4 blue ones, and 2 red ones. So what is the probability of pulling a green marble from the bag without looking? Suppose you dip your hand in there and pull out a marble without looking. Because if you look, you may be influenced by what we call bias. Bias. So we don't want you to be biased. Just dip your hand into it and pick a ball. What would be the probability that the ball you got is green? So you count the number of green marbles. There are 3 here, and we have a total of 10. That means the probability that it is a green shall be equal to the number of green balls divided by the total number of balls, or rather marbles. These are marbles, we are told here. So it will be 3 out of 10. Take note of that. Just take the number of possible successful outcomes, so that represents 3 green marbles divided by the total number of marbles, which is 10. So we can express this 3 over 10 as 0.3. You divide 3 by 10, it will get 0.3. Or you multiply by 100, it will give you 30%. It's very rare to express probabilities as percentages, but it's allowed. Alright, let's look at this spinner here, which has 8 equal divisions. If you count these, we have 8 equal divisions. When you press the spin button, this is going to spin. It will go round and round and round, and then it will land somewhere. What is the probability of the spinner landing on a blue sector? So we have a blue sector here. And what is the probability of the spinner landing on a red or green sector? Red or green sector. What is the probability of the spinner not landing on green sector? Alright? So let's start by looking at probability that it is blue. Probability that it is blue, you just count the number of blues you have in this spinner. Notice there is only 1. So it will be 1 divided by or over 8. The total number of events, it's 8. You have 1, 2, 3, 4, 5, 6, 7, 8. 8. But one successful outcome is going to be blue here, only once. What is the probability that it is red or green? Probability that it is red or green. So just count the number of reds plus the number of greens. So you have 2 reds and 4 greens. That makes it 6 altogether. So you have 6 out of 8. But remember that probabilities need to be expressed in their simplest form. So here this is 6 over 8. 6 over 8. So 6 over 8. There is a number that is common to both there. And that is a 2. A 2. Okay. So in this case, you divide through by 2, you get, divide by 2 here, it will be 3, divided by 2 here, it will be 4. So you have 3 over 4 as the final probability, the probability that the spinner lands on the red and the green sectors. What about the probability that the spinner lands on does not land on a green sector? So here you have 4 greens. Alright. So what is the probability that it is not green? So to do that, remember that the total probability is 1. Alright. If we take all the probabilities, add them up, it's going to be equal to 1. So the probability that it is a green is 4 out of 8. That it is not green is 4 out of 8 as well. So just count that which is not green. So you have red, blue, and yellow there. Or this yellow or orange should be well, yellow for me. Not good at colors. Alright, so the probability that it is not green, you simply count the sectors that are not green and express that as the probability. So it's going to be 4 out of 8. Again, you divide by 2, you get 1 over 2 as the probability that it is not green. Can you look at this one again? This spinner has 16 sectors. Can you work out the probability that the spinner lands on dark blue? So dark blue is this one here and this one. There are 2 of them. So what is the probability that it is going to be dark blue? So you count the number of dark blues over the total number of sectors. Suppose that the probability of a spinner landing on yellow is 0.2. What is the probability not landing on yellow? The probability that it lands on yellow plus the probability that it does not land on yellow is equal to 1. Remember, the total probability of an event is equal to 1. If you add all the probabilities of events, it's 1. So given that the probability that it is yellow is 0.2, what will be the probability that it is not yellow? So just in this case, note the positive one, subtract from 1, it will give you the negative 1. Check that 0.2 plus 0.8 is giving us 1 here. So the probability that it is yellow is 0.2. Then the probability that it is not yellow is simply 1, which is the total probability, the certainty, minus the event that has been mentioned there. So if the probability of an event occurring is P, then the probability of it not occurring is 1 minus P. For example, suppose you are looking at an event of flipping a coin. Suppose a coin shows heads. Then the probability that it's not a head is going to be 1 minus half, because the probability that it is a head is 1 over 2. That means the probability that it is not a head is going to be 1 minus half, which is also half, representing a tail. So supposing a spinner has green, red, and blue sections, Landing on red is twice as likely as landing on green. Twice. Can you fill in the missing probabilities? Landing on red is twice. Landing on red is twice as likely as landing on green, twice. So the probability of landing on a red is twice this, according to the statement. So twice this, you multiply by 2, it will give you 0.52. But since the total probability is always equal to 1, so to get the probability that it will land on a blue, you simply add these two up and subtract the result from 1. It will give you the probability that it is a blue. Please try to sum these up. You get a total of 1. I hope you capture that. Alright. Let us look at a very important concept in probability studies, which is called sample space. A sample space is simply defined as the total number of outcomes. All outcomes together shall give us a sample space. So this is a diagram showing a sample space of 2 die. We have a die with 6 sides and another one 6 sides. So the first one is thrown here. These are the outcomes 1 to 6. The second one is also thrown, so that the outcomes are also 1 to 6. And then the outcomes on the first die are added to the outcomes of the second die to find these values here. So for example, 1 plus 1 is a 2, 1 plus 2 is a 3, 1 plus 3 is 4, and so on and so forth. So you get this sample space here. Alright, so all these are the outcomes. Together they form a sample probability space. Sample space, Alright, those which have colored. So what is the probability that the number obtained shall give us a total more than 5? So all you have to do is look at how many numbers are greater than 5. So it will be 6, 7, 8, 9, 10, 11, 12. So you just count them. 1, 2, 3. You count all of them. Count all these. Count all of these. From 6s, so you have 5 6s and 6 7s, 5 8s, 4 9s, 3 10s, 2 11s, and 1 12. So just add them up. Alright. What is the probability of getting a total less than 10? So you look at how many numbers are less than 10. Just count them. Count them, what you find over the total number of outcomes here. So if you look at the total number of outcomes, you have 1, 2, 3, 4, 5, 6. So we shall have 6 times 6, which is 36. So whatever result, you divide that by 36. So in the first case here, let's see how many numbers are more than 5. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So it will be 26 out of 36 here. The probability that the total is less than 10, you count how many are less than 10. So you start from here. So you have 4 9s, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So it will be 30 out of 36 there. And so on. So you can continue answering the rest of the questions there. So This is a sample space. Alright, can you go ahead find the rest of the outcomes? You can make up your own questions. What the probability that the number is a 12, the number is a 1, the number is a 7. Sometimes you have two different events that are combined to provide a space. To provide a sample space. All right. For example, suppose you flip a coin and throw a dice. And then combine the outcomes of the two events. You shall have a table like this one. So when you throw a dice once, this is a 10-sided dice. It will show these outcomes: 1, 2, 3, up to 10. While when you flip a coin has two faces, head or tail. It will give you a head or tail. So you can combine these. For example, here combine head, a 2 and a head. It will give you this one, 2 comma head. It means you have combined this and this. Here you combine a 7 and a head, you have this. You combine an 8 with a head, it will give you this one here. So you can complete the table with the rest of the outcomes. For example, here combine a 5 with a head, it will give you 5 comma head. Or 10 with a tail, here it will be 10 comma tail. So complete the table. This is for you to do. You can do this one. Okay, complete it. Just complete, and then use. When you complete it, it's going to look like this. So how many outcomes are there? Just count. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 outcomes, from which you can calculate the probability of getting a head and an even number. So all you have to do is look for even numbers. Even numbers are those that are divisible by 2. So a head combined by an even number, you have this one, the first one, then this one here, then this one, then this one, then this one. 2 head, 4 head, 6 head, 8 head, 10 head. Those are even numbers. Alright, so how many do we have? You have 1, 2, 3, 4, 5. That means it will be 5 out of 20 of them. What will be, or what is the probability of getting a tail and a square number? A tail. So you go down here. Square numbers are numbers such as 1, 4, and 9. So there are 3 numbers here, because when you square 1, you get the same one. This 4 is 2 squared. This number here is 3 squared. So you can get probability there. So you have 1, 2, 3 numbers out of 20. So you can make up your own questions based on this sample space. Other combined events: 2 four-sided dice are thrown and the numbers added up together. So we have a dice, two dice that are four-sided. 1, 2, 4. Maybe this is a cube or something, or cuboid. So it has four faces. So they are thrown and the numbers are added together. The sample space is going to look like this. So we have 1, 2, 3, 4. You add these numbers up. So you have 1.1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, and so on. So you have a sample space here. So what is the probability of getting a total more than 4? So check how many numbers you have, how many outcomes. You have 16, Yeah, if you count these numbers, there are 16 of them, the ones that are colored, 16. So count the numbers that are greater than 4. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be 10 out of 16. What about the total number less than 8? So you can also do the same and they answer that. What about a number picked at random is giving a total of which is a prime number. Remember, a prime number is a number that does not have any other factors except the number itself and a 1. So which numbers are prime? Here I see a 2, a 3, a 5, and a 7. So just count all of them and then over the total number. What is the probability of getting a total that is at least a 3? At least a 3. In other words, anything below 3 and up to 3. Yeah? So in this case you have 2, 3, and 3. A total of 4 or 5. You can do that. The same number on both dice. Okay, here you have to be a bit careful. So here you have a 1 and a 1. To give this a 2 and a 2. To give this one a 3 and a 3. So you count the numbers will be 2, 4, 6, and 8. And then you divide by the total number of outcomes. Using fractions to find probabilities. Suppose we have this as our sample space. Use the table to find the probability of getting a score of 3 or 4. So the probability of getting a score of 3 or 4 can be written as P 3 or 4 like this. So this is the same as the probability of getting a 3 added to the probability of getting a 4. So the probability of getting a 3 is going to be 2 out of 16, while the probability of getting a 4 is 3 out of 16. So just add the probabilities together. You get a total of 5 out of 16. Here we meet a very important terminology of an or condition. When you are told find probability of event A or B, you simply add the individual probabilities for each event. That's what we are saying here. What about the probability that it is a 5 or a 6? So you take the probability that it is a 5. Just count how many 5s you have. So you have 4 of them here, plus the probability that it is a 6. So we have 3 of them. So probability that it is a 5 is going to be equal to the number of 5s, which is 4. There are 4 of them, divided by the total number of outcomes. Similarly, the probability that it is a 6, you take the number of 6's, which is 3, then you add them together, it will give you this, 7 out of 16. What about the probability that it is a 2 or 7? How many 2's do we have? You see here we have 1, 2, and the 2 7's. So you add their probabilities, it will give you 3 out of 16. It's a simple thing to do. So probability that it is a or B, just add the probability that it is an A plus probability that it is a B. Suppose we toss a 6-sided dice, and the results are added. So here we add the values. We have 1 plus 1 and so on. So you shall have this sample space, the results when you add. 6 plus 6 is 12. Alright, so when you add these up, you have a situation like this one. Can you work out the probability that it is a 3 or 4 by adding fractions? So you count how many 3's are there and how many 4's are there. And what is the sample space? This is 36. Yeah? So probability that it is a 3 or 4 is the same as probability that it is a 3 plus the probability that it is a 4. In this case, there are 2 3's here. So 2 3's, it will be 2 out of 36. And the 3's, 3 4's, 1 2 3 3, it will be 3 out of 36. Then you add them up, you get 5 out of 36. Can you proceed to work out the probability that it is 5 or 6 by adding fractions? You have a situation like this one. Okay, so that's very important. When you have two outcomes, probability that it is either one of them or the other, just add the probabilities of the individual outcomes. Lastly, let's look at a situation of a girl called Tandizo. So Tandizo works out the probability of getting a prime number or an even number as 33 out of 36. Something isn't right about this. Can you identify what is wrong with this one? Explain why Tandizo is wrong. Tandizo is wrong here. Okay, so let us see, or let us call all the even numbers in yellow. So even numbers include 2, 4, 6, 8, 10, and 12. How many do we have? And also color all the prime numbers, because Tandizo is working out the probability of getting a prime number. Remember, prime numbers are numbers that do not have any other factors except themselves and 1. While even numbers are those that are divisible by 2 and they leave no remainder. In other words, they leave a remainder of 0. Alright, so let us color all the prime numbers. Alright, so you see here that a 2 is both even and prime. 2 is both even and prime, meaning that it does not have any other factors except itself and 1, and also it is divisible by 2. So the probability that it is prime number plus the probability that it is even must exclude the probability that it is a 2, because the 2 there is appearing in both characters. So the result will be 15 out of 36. Those are prime numbers, and you add this to 18 over 36. In this case, prime numbers. even numbers. So you subtract the probability that it is 2. Thank you very much. We come to the end of today's lesson, in which we were looking at the concepts used in probability and how probabilities can be worked out in different situations. The topic continues in the next lesson. For now, I've been your teacher, Mr. Poch Lola, once again, representing Black Slice Tuition Providers. I wish you a wonderful day. For now, we say bye-bye.